So this was actually G. Venkatesh's idea. So he had actually been doing this physically in schools. So the idea with having a card, 30, 40 cards, is that it is a table with 5 numbers and ask you what is the max, you can kind of look at it and tell. And it's not in one place. So you have to kind of go through the cards and understand these basic iteration and these processes. Of course, traditionally, people in science have used programming to handle some data calculations and all that. But even in the need for programming, computation is now widespread. And of course, on a personal level, everybody is managing things on spreadsheets and things like that. So implicitly, they are doing some calculations, computations. So I think this is a skill which I think now becomes more fundamental. How to deal with information and how to effectively process it. So as we discussed before, I think right now possibly the most valuable advice to anybody is to make sure that you are open to
Hello everyone, welcome back to Stories of IITM BS, and today we have one of our most loved and favorite professor, Professor Madhavan here. So sir, very warm welcome and thank you so much for giving the time to be here.
Oh, it's a pleasure to be here.
Thank you sir. So I think most of the viewers and the students who are watching this, they already know you, but still I would request you to introduce yourself, tell us a bit about yourself.
Yeah, so I'm a computer scientist. I'm at the Chennai Mathematical Institute, so I'm not actually a part of IIT Madras, but I was involved with planning and designing the IITM BS program, and I have been teaching, as you know, a few courses here. So my main interests are in computer science, but here I've been teaching some things related to computational thinking and programming languages, which are kind of interests of mine. So I've been teaching at CMI for more than 30 years now, so I've been a faculty member since the early 90s, and before that I studied at IIT Bombay.
Oh, so you completed your graduation in CSE from IIT Bombay?
Yes, long time ago, almost 40 years ago now.
Amazing, sir. So what actually pushed you towards computer science? And I think 40 years ago, that too at that time, it must be a very new field, emerging field in India. Did you always wanted to get into this?
So I was interested, I was somehow fortuitously introduced to some ideas of programming when I was in school. And though it was not very common, but there were these kind of personal computers at that time which were running this language called BASIC. So you could connect them to a small screen or a TV and do some simple programming. So that interested me. I was also generally interested in maths, and this combination, of course, a lot of the decisions are not made by at that age by the students themselves. So it was a combination of what I was interested in and what was available and what my parents thought was a good idea. So I'm quite happy that it worked out this way. I don't think many people know even now, but certainly then most people who are getting into computer science didn't really know what it meant.
Yes.
So I think it was a bit of luck.
Definitely. And sir, for your higher studies, you chose to go abroad and then come back to India. So what in the last year, after completing your graduation, what were you thinking that, you have to complete this, and you went abroad, and then what made you to come back to here in India?
Yeah, so actually that my going abroad was not as direct as that, because actually I started my PhD in India only. So I moved from Bombay to Chennai, and at the Institute of Mathematical Sciences, which is quite close to the IIT campus. And then midway through my PhD, the institute where I am now, CMI, started, and I moved as a PhD student with my advisor. But essentially the problem was because of, it still is a problem, but in those days especially, because moving from an IIT system to a university system, because the institute PhD registration was through the university, so there was some incompatibility of BTech versus PhD. So for that reason, mostly I ended up having to register in Denmark and do my PhD in Denmark. So I didn't spend all that much time, less than a year actually I spent in Denmark. So coming back to India was always a natural solution for me.
Okay, sir. Wonderful. So then how did your journey after this PhD begin? And when this program come to you, the IITM BS program, when they approached towards you that this is going to be the world's first online graduation degree, how did you see it as? What were your first thoughts hearing about this degree? Like, were you actually able to, switch from a classroom mode to an online mode, recording the lectures on the green screen and being camera friendly? How was it for you?
Yeah, so actually I had been doing some online recordings for quite some time, and I already had 2 or 3 NPTEL courses which I had recorded. So recording lectures and being in front of a screen was something I had got used to, and also the how to adjust your teaching when you don't see the audience, when the audience is kind of invisible and there's no reaction. But as I mentioned in the introduction, actually it was not that they approached me to join the program, but rather that I was part of the group that actually designed the program. So in fact, there was so the person who teaches computational thinking with me, G. Venkatesh.
Yes.
So he was, I think, to me at least, the one who originated this idea that how can we make an IIT degree accessible to a larger number of people.
Yeah.
So he proposed having, because NPTEL was already well established with the recording technology, with the with the administration to take care of exams at a number of centers around the country. So a lot of the pieces were already available in terms of the infrastructure needed. So then it was more a question of whether an entire, instead of having individual courses in an NPTEL like mode, whether you could actually string together an entire program with different components, including labs and exams and all that, in such a way that people could actually do it from different places in the country, but also join without having a very restrictive entrance exam thing.
Yes.
So we went into a lot of discussions about this, how to do it, and of course over the years a lot of things have, as the program has progressed, various things have to adapt to what happens in the ground. But I think by and large, whatever was initially planned has more or less been the broad framework. So there have been challenges which have been addressed, as exactly like how to conduct labs and how to do projects, these kind of components which are not normally part of an online NPTEL type of course. So it has been a lot of fun and a lot of learning about how to deal with a different type of program and a different category of students from those who are on campus. So I think, but yeah, I think it was a kind of an overall natural progression over the last 10-15 years of moving to teaching online to this.
Yes, amazing. So, sir, now that you touched upon computational thinking, that is the very basic foundation level course. And to a lot of students who come from a non-technical and non-coding background, actually, it acts as a very base for to learn the higher languages like Python, Java, SQL further. How do you think that computational thinking forms a base for them? Like in the whole course we saw, but still, what are your thoughts that is computational thinking should be taught to the students as a very basic subject?
So I think that increasingly, as you see around, even in other subjects, even in, of course, traditionally people in science have used programming to handle some data calculations and all that, but even in social sciences and even in life sciences, people are doing a lot more of computing. So the need for programming computation is now widespread. And of course, on a personal level, everybody is managing things on spreadsheets and things like that. So implicitly, they are doing some calculations, computations. So I think this is a skill which I think now becomes more fundamental, how to deal with information and how to effectively process it. And ideally, it should be something which is also part of the school training.
So do you also think that during maybe 8th or 10th class?
Yeah, so I think we need to make it kind of more explicit. It doesn't have to be a separate subject because that would take up too much of space. But I think wherever we actually do a lot of, in maths especially, but even in science and all in school, where we handle information and we derive some things by looking at the values and all that, that can be kind of explained as a computational task. And that idea that these things can be done systematically and efficiently is something that I think everybody should understand. Even if, so programming is a different level, because then not everybody obviously needs to be able to write program in a given language, because you do have now a lot of applications which a user who doesn't have familiarity with programming can get their job done. But then if they don't understand what's going on behind the scenes, they're not maybe making best possible use of these kind of applications. So that way, I think the idea of computational thinking is much broader than programming. And it's more or less like, I think it's becoming like arithmetic and all these either basic skills that we expect all students to know, that everybody should have some awareness, because at some point or other it will touch in some aspect of what they are doing. So I think that from that perspective, and then from this program's perspective, as you said, the assumption was that unlike say JEE or something where everybody more or less comes from a science background and you can start off directly with programming, we wanted to take it more gently, so sort of separate out the concepts of computational thinking from learning a language, because otherwise learning a language,
so language independent computational thinking.
Yeah, because otherwise a lot of time just gets spent in understanding what the language does, and less time is spent on problem solving, and that problem solving should really be the focus of the initial introduction to programming, not whether you should put a colon here or do something there.
Yes. And when you were teaching the course, sir, in the computational thinking, we saw you used examples of that cards. Yes. How did that idea come up? I mean, that was very interesting to see. A lot of students.
So actually, so this was actually G. Venkatesh's idea. So he had actually been doing this physically in schools. So when he had been trying to do the same thing, so he would go to a classroom and actually physically use these cards in the classroom and try to explain. So the idea with having a card, 30-40 cards, is that it is large enough that it's difficult to see by just, I mean, if I just give
like
you a table, if I give you a
actually
table with 5 numbers and ask you what is the max, you can kind of look at it and tell me. So this is, and it's not in one place. So you have to kind of go through the cards and understand these basic iteration and these processes. So the challenge was that we said, okay, let us try that here, but how do you do that interactive thing? So this was one of, I think, possibly the first innovative thing that we had to do, which was how to make a teaching method which was inherently interactive.
Yes, and actually connecting to real world also.
Yeah, but how to put it online, right? So then there was the suggestion that came up that maybe we could make it a conversation so that interaction could be captured. And then, of course, the NPTEL team was very resourceful, and after a couple of iterations on how to, because we need to see not just the conversation but also what is happening on the cards. So they set up this special room in which they had a camera which was mounted on the ceiling down on the card, and then they had a very talented cameraman who would kind of switch between these three. So I think a lot of innovation went into that course, but both in terms of, as you said, why teach computational thinking, how to teach it, but also in how to deliver it online. I think that has been a very positive outcome in terms of producing something different, which this course has produced.
It is very, definitely it's a miraculous outcome, because I myself belong to a known coding background, and when I learned computational thinking, the languages became much more easier. I felt like it was kind of a stencil for me. So it laid the foundation.
Exactly, that's the idea. So I'm glad it has worked in your case.
Yes, and in many of my friends' cases also. So that's actually the most interesting part. Okay, so sir, coming to the diploma level of this degree, you have taught many courses over there also. So what do you think, like initially what students see, like they see Python as a very easy language and Java as a very hard. So between two, what would you suggest, learning Python first or learning Java first?
Yeah, so this is a difficult question. It really depends on what your final use is going to be. So for many people who are working in a data science kind of role, where their main focus is on actually using programming as a tool to do some analysis, insights and all that, Python is really very natural because it has a lot of libraries and so on. But if you are on the other side developing some kind of platforms, or you want to make some, so you're really building software platforms where these things, so you're not doing it only for yourself, but you want to create something which other people can use, then you need to go beyond Python. And a lot of the choices in programming languages are not dictated by in some sense by whether it's a good or bad or better programming language, but industry-wide what people will support and what is seen as the standard. So in that sense, Java has become a kind of a very widely used language. So if you learn Java and if you do something in Java, it is easier to combine it with other things, and also it's easier to convince people that what you're doing is. So if you pick a language which nobody else is familiar with, then maintaining the code, developing it, adapting it becomes harder.
It gets a bit.
So I think if you're doing system level building systems, I think you would need to use something like Java. Python is probably not the right language. But if you're doing basically using it as a tool for some
Building something.
for some exploration and doing some analysis, then Python is more than enough.
Okay. Wonderful, sir. Actually, after this, I have a question for you. Like during this whole journey, and you must have seen a lot of students showcasing their projects to you, asking your doubts to you. Do you remember any very funny moment a student asked you a question, or maybe a project you have seen that is like memorable? Still, you can recall that.
I think that's a very hard question. I can't give you a good answer to that. So I think I'll have to pass on that question, because of course you say, but the thing is that you must remember that as faculty, we don't really interact directly with the students that much, because the instructors handle most of the queries, and in the courses which I have taught, there are really no projects directly which I have to be involved in evaluating. So my interaction is very indirect. So either in the rare cases, one or two people might reach out over email because there is something they don't understand and it's not been clarified even by the instructor, or when I come for something like paradox or something, I meet people, but then it's more a casual social conversation, not something about the course. So
coming to paradox, the best part of this online degree, students were not actually expecting a offline fest to be here. How did you feel when you first came to the paradox, interacted with the students?
Yeah, certainly. Yeah, I think in the beginning, I think nobody had really thought about these angles too much. And of course, in the first 1 or 2 years of the degree, so one thing I should again mention is that the idea of having an online degree was quite independent of COVID and all that. It just coincidentally happened that at the time when the online degree started, also other programs had to go online because of COVID. But first 1 or 2 years, there was no question of doing anything on campus, because anyway the campus was closed. So I think when the idea came up of doing something on campus, I think everybody was quite, I mean, it was not a discussion which had come up before, but everybody was very enthusiastic. And I was very happy the first time when I came here and interacted with students. Before that, there had been these kind of meetups online and all that, which have their energy, but it's nothing like
the paradox.
Having a few thousand students. So I think it has been a great bonus to be able to have that as part of this otherwise online degree, because I think that's a way for students to, of course, meet and know each other, but also for us to know more about, because so many students come who are, they are very talented in different ways, and those aspects you don't get to see, of course, in an online degree. So they are able to put up some performances and showcase their other achievements, not just their academic. So it's great. It's been a great, I think, great addition, and I'm glad that it has become kind of a ritual to have it every year.
Yes, definitely. Did you visit this year Paradox too?
This year, unfortunately, I was traveling, so I was only able to come for the degree function, which was the day after Paradox. I missed Paradox completely. Last year, I was there in Paradox, and I even gave a kind of a technical talk or something like that.
Yes. No, the students really enjoy the feedbacks form that we had received. They were mentioning a lot of good stuff about you, sir. Okay, so sir, one more question I have. Like, you come from a like you did your graduation in computer science only. Now, when you look back like 40 years ago and now and in the future, what do you think its scope is? Like, how is it going to shape in the few upcoming years?
Yeah, this is, I think, a big question which a lot of people are asking. I don't think there are any clear answers. So about 30, 40 years ago, I think computer science was a very open area, because there were not many programs specializing in computer science, nor was there, I think, a clear idea what a computer scientist should be learning. So if you did a BTech in computer science from different IITs also, you would probably learn quite different things depending on what faculty in that IIT thought was important. And now, then in between, it became a very clear thing that, it was all about developing software and all that. Now, it's changing again, right? Because you have on the one side, you have very sophisticated systems being built for doing AI and all that. How much of that is computer science in the traditional sense and how much of that is different is one thing. Second thing is, these same systems now can do a lot of the routine software development coding. So there is not that much of a role, I think, in the future for people to just do basic programming. So I think what it means to be a computer scientist, I think, is kind of changing quite rapidly. So the kind of work I do as a faculty member outside my teaching is more theoretical, and that part will always remain, but that's a minority of computer science. I mean, basically you're looking at more fundamental questions about what computers can do, cannot do, and things like that. But actually, if you look at the practical side, building computational tools, how many of the people who are building these tools actually need a computer science background, it's not very clear. So I think already I think computer science programs are beginning to start rethinking what skills they should emphasize, and also I think job roles are also changing. So I think it's very hard to predict actually what is going to happen, but one thing is clear is that in the next few years there's going to be a fairly big shift in focus and what kind of roles are there.
One more question that everyone is asking, sir, and I will ask it to you also. Will AI take over the jobs of people?
Yeah, this is again a big question. See, of course, what we have been seeing is quite rapid and changing, and a lot of, I mean, essentially things that we used to think of as human jobs, right? These are not, it's not like a robot in a factory taking over some repetitive process that a human being is doing and doing it more accurately and faster, right? This is more like something where you think you're putting in some creativity. So not just programming, but even things like, preparing, say, a poster or doing something like that. And these things, AI tools are able to do. I mean, obviously, when it comes to an art object, they are not going to produce something which is as possibly aesthetically good as. But if you're just doing it as a functional thing, you want to make a poster for an event or something like that, you can get a good set of first choices from AI and then refine them. So the role of the expert is more to take a collection of possibilities and find a good one, refine it. And similarly with coding also, you can, if you have some idea about what the code should look like, a lot of the initial work can be done by AI, and then you can focus on making sure it doesn't make mistakes and also just fixing it and making it better. So from that perspective, it looks quite likely that a lot of current jobs are going to get in some sense replaced or at least automated.
But humans will be over AI.
No, but I don't think that these systems on their own can do the job without. So I think it's still, I don't think it's ever going to be the case that these things can be trusted in a way to make the right.
To just completely replace a human.
Yeah, so I think there has to be some, not just oversight, but also some quality control and some kind of correction which has to be. So now again, the difficulty is understanding how many of the people who are currently in that, in the more basic roles will not be required anymore, and what will be the nature of the replacement role. So traditionally, this has always happened that when something gets automated or mechanized, there are new kinds of jobs which get created. So essentially, if you have the correct training, you can move from the old type of thing. But usually it happens over a longer period of time, when mechanization happens, or even when the early computerization happened, when things like banks and all were computerized, there was a lot of resistance initially. People were worried that, jobs of bank employees will get lost and all that, but it didn't happen because there were enough things for.
Definitely, yes, for them also.
Yeah, but now the thing is that happened, I mean, already that was fast, but it was still happening over a period of sort of 10 years. Now it's happening over 6 months time. So then it's a real challenge because it's very confusing for people who are studying to understand what direction they should focus. And also people who have recently graduated and have spent a lot of time learning some skills. It's not very comforting to say that, forget everything that you have learned and do something else, start again kind of thing. So that I think is the biggest social challenge, that the speed at which this is happening, even though I would say in principle there will be replacement roles which are new.
Okay.
The challenge is to get the people who are currently doing these traditional roles to switch over in a painless way, in some sense, as painless a way as possible. And if that doesn't happen, there can be a lot of unhappiness and that lead to a lot of other issues. So I don't know, but it is a concern. Whether it will take over, it's not very clear, but it will certainly make it's already making and it's going to make a big impact on how we perceive job roles, I think.
Definitely, sir. So, what do you think the best use of AI can be regarding these fields, the mathematics, computer? I mean, already like we have products, ChatGPT and models and everything. These are very nice. But do you have something in your mind that you wish that AI to be used responsibly? Because a lot of people, I think, I would like to have your opinion on this. A lot of people use too much ChatGPT, and it has been proven in research also that their brain functioning has decreased. What would you like to say over this topic?
Yeah, so I think that as I said, if you already have a reasonable amount of experience, expertise in a subject, then I think these tools can be very good to boost productivity, because a lot of mundane things which you spend time on and where you may even make silly mistakes because it's so tedious, you get it automated. So it's very much like, instead of doing long multiplication by hand using a calculator, the chances of your making a mistake are less, and also the speed at which these processes get over, and then what you use that multiplication for, you can focus on. But as you said, the problem is from a student perspective and even from a teaching perspective, how do you get students to that level of knowledge or expertise where they can get this benefit?
Yes, definitely.
Right? Yeah. Because again, you spoke of a study, so we had not a study, but we had some kind of a seminar where we had invited people from different industries to talk about their experience with using these kind of systems. So one of them was actually in a software company, and their observation internally was, by some not very formal but a kind of general observation, was that if people who had 3 to 5 years experience or more were more productive using these tools, but those who had fresh in less than 3 years, they were actually slower, right? Because the mistakes that were made were in some sense too maybe subtle for them to fix, right? So they make so you need a certain judgment to know whether it's a mistake or not, and then otherwise you run it and then you find the mistake later, and the later you find it's a mistake, harder it is to fix. So there is a clear thing that in their opinion, that the people who were less experienced were actually harmed by this. And the other thing, as you said right now, is that as a student, if people are increasingly taking whatever, if you have to write an essay or write a letter or do anything and just ask ChatGPT to do it, you are basically possibly not developing those skills, and maybe even harming the development of those skills. So the other study which I read recently was basically it doesn't matter whether you're a student or not. So supposing you're a manager, so people use it everywhere, right? So you use it for making a PPT. You have to make a presentation to some group.
It's very handy and very easy.
Yeah, but generally what they observed is that in general, if they ask people to write something, make a presentation, write a letter, whatever, and half of them did it traditionally and half of them did it using generative AI, a large fraction of the people who did it using generative AI could not kind of tell you a day later what was in their presentation. So they themselves kind of
unaware of
that. So they kind of, in the same way that when you attend a presentation and you're not paying attention, and you might have a broad idea, but if I ask you what were the 10 points on this, you may not remember. So in the same way, but the people are actually presenting. But because it's kind of second-hand presentation in some sense, they didn't prepare the presentation, they're just reading out what is in front of them. It doesn't register, right? So even from your own role perspective, if that whatever you're generating has to serve a purpose and you're not paying attention to it, it doesn't help you. So I think these are all concerns. I think nobody is yet clear how to, the concerns I think people have started at least documenting.
Yes.
But how to get around these concerns, I think, is a very challenging problem. I don't think there's a clear answer. So even in conventional programs, forget about an online degree. What is it that you should do to adapt education to this whole thing and train people to use? Because you can't train people to do only traditional things, because in the job market, wherever they go, they will have access to these tools. So you can't assume that they will work without these tools. But if you train them to use the tools, then how do you make sure that they use it in a responsible way, as you said, in a way that supplements what they already know and not as a replacement? So this is a big challenge.
Okay, sir. So let's come to the fun side of this podcast. So I will just ask you to explain a few things like you would explain to a 10-year-old. A few terms.
Okay.
So the very first question is this: the work that you do, how would you explain this to a 10-year-old?
So the work that I do, of course, one part is easy. I'm a teacher, and every 10-year-old understands what a
Yes.
teacher is. But if you ask more specifically, like, uh, so I think most 10-year-olds now understand computers. So I would say that, you use a computer to do something, and what I would like to understand is whether that computer is doing what it. So just like a mechanic checks whether the car is running properly or your cycle is running properly,
Yes.
I would be like a mechanic who would like to look at somebody who is supposed to write something that works on your iPad or your computer and check that it is doing what it is supposed to do.
Wonderful, sir. Amazing.
Yeah.
Also, algorithm. How would you make a 10-year-old understand algorithm?
So I think the easiest way to explain algorithms is through something that they know. So for instance, I think traditionally cooking has been one example. So when you you would ask a 10-year-old, how would you, for example, what happens, what do you think needs to be done if you want to make, say, a dish, you want to make some,
Make pancakes or maybe waffles.
So you need some, obviously some ingredients, and then you have to have some equipment, and then you also have to have some way in which you mix them together in a particular way. So you need to know how much of each you put, and then there is a procedure to do it. Like you need to heat something, you need to put some oil or butter, then you need to spread it out. So this whole step-by-step thing is basically a sequence of instructions on how to start with some raw materials and come to some finished product. So an algorithm at one level is just this.
Okay.
But at another level, an algorithm is also saying something about doing things efficiently. Right? So for instance, suppose there is a step in your process where you have to put something in the fridge and cool it down for half an hour. Right? Then ideally you should do that first, because then while it is cooling in the fridge for half an hour, you can do other things other than waiting for half an hour just for it to cool. So can you take the steps that have to be done and can you do them in a different order or combine them in a way where you take less time and so on. So that is a second part of this thing. Once you know what to do, how do you do it faster?
Oh, very nice, very nice. Even I related it well, sir. Okay, last one, loop.
Loop.
Yeah, the term loop. How can you make him or her understand that?
Yeah, so loop is something that you do again and again, right? Until you have done it enough times. So one thing could just be if you are maybe taking, you have to carry 20 glasses from this room to that room, and maybe you can only carry 2 at a time without breaking them. Then you have to go back and forth, and because you have 20 glasses, you have to do it 10 times, right? Now, that is one kind of a loop. Another kind of a loop could be that you have to carry, maybe there is a big stack of newspapers and you have to carry it from here to there. In advance, you don't know how many times you have to go, but you know how much you can carry. So you carry one batch, and then when the batch gets over, then you stop doing it. So you could either have a loop where you know in advance that you're going to do it a fixed number of times because you know how much work is required, or it means that you keep doing it until the loop is no longer needed, that job is finished. And then at each step, it depends on how many things you do. Like carrying it from here to there could also involve take 2 glasses from here to there, but also open the cupboard and put it in the right place.
Yes.
So there could be some extra work which you have to do for in each of these rounds. So each round is, and then the number of rounds together is basically the whole loop or iteration.
Amazing, sir. Okay, so sir, wrapping it up and going towards the end of this podcast, what is that one advice you would like to give to BS degree students or maybe to other students who are going to pursue their career in data science or going ahead in this field? What's something that you would like to tell them?
So as we discussed before, I think right now possibly the most valuable advice to anybody is to make sure that you are open to new things. So I think that we have gone well past the stage where you learn something at college or whatever level and then you apply it for the rest of your life.
Yes.
So I think being receptive to new ideas, to new
changes also.
And possibly even to drastically changing what you do, because it also happens that when we are, at this early age, in our early 20s, we have certain interests, but the kind of opportunities that come we realize it doesn't match up to what we thought, and then you might find other things which are more interesting, right? So you should be flexible also, so both open to learning new things, but part of that can involve also shifting direction, doing something different. So don't be afraid of change. I think that is the main thing I would say.
We should actually accept the change.
Yeah, because change is, I think, now going to become more and
It's
more a
inevitable also.
part of our daily life. I don't think anybody can expect that they are doing the same thing. It's not like a very old style thing where you join an organization and you work in a very simple role and you retire from that role. I don't think that kind of thing is the normal
Going to
thing
be
anymore.
there. Yeah.